Hi there, we're going to look now at exercise 18B.2. Now we've already seen hypothesis test, normal hypothesis test. You should recall that if x bar is normal, we're looking for this mean. And it might be the mean is say 30, and the x, when the x bar is, it might be say 9 over sample size of 16, and that gives me a normal distribution curve as such. And you might recall that what we do is we do this sample and we say h naught mu equals 30, and we might have a belief that this mu is not 30. We might think in actual fact mu is greater than 30, and we're testing to see if this is true. And so what tends to happen is you get given a value. It might be 32, for instance, and you might say to yourself, well, is 32 big enough to make me conclude that it was 30, or it was actually bigger than 30? Because even if I got 32, it's only a small sample. So all we're doing is we're saying, is 32 far enough away from what I think it is to make me think something's amiss here? Sometimes it is, sometimes it isn't. This value here is given to us. Now, imagine a scenario where we set it up, this normal distribution, and it's exactly the same. X bar is normal 30, 9 over 16. But imagine with this sample, I don't tell you what my value is. All I tell you is I want to know the value at which I would say it is far enough away from 30. And we could write an x there almost, and I want you to find the value of x such that it gives me a probability when I do it. My probability is less than the critical, the significance level. It might be 5% or something like this. So what we're looking for is for what value of x is it far enough away for this probability to be lower than the significance level, usually 5%. This x is called the critical value. It's the value at which we go, do you know what? It is so far away from my 30, I would now say that I would reject h0. I think h1 is right. I would definitely reject h0. It seems likely to not be true. So that's what we're trying to find. We're trying to find the x value for which we would reject h0. So look at the class width for this. I think I've got an example for you. Yes, here it is. It says mu equals 60. So let's just draw a little picture over here. And we've got a normal distribution. It says mu equals 60. So I'm going to chuck here 60. And it says, so I'm going to say x is normal. 60, 1. But it does also say, and notice if sigma is 1, sigma squared is also 1. But notice it says I do a sample of size 5. If I do a sample of size 5, then obviously my x bar now becomes normal 60, a fifth. And I want to try to find these x values. Now it says it's a two-tailed test, so let's just highlight what that means. Of course, it means mu equals 60 is our null hypothesis, and our alternative hypothesis is that mu is not equal to 60. So on that basis, it says for a two-tailed 5% test. So we're looking for this middle section. Now notice it's two-tailed, so I need a value at each end for which I would reject h0. I would say that mu is not 60. I'm looking for those two values. So x there and an x there. Remember this middle section is, well, it's a 5% test, so I think I've got 95% left in the middle, which kind of means I've only got, even though it says 5%, I've got 2.5% each end because it's a two-tailed test. So I'm just showing the 2.5% each end. And now because of that, notice what I've got to do. At the left-hand side, notice I've set my area on my inverse normal button. I've set my area to be 0.025. My sigma, yeah, that makes sense, 1 over root 5. My mu is 60, and I type all this in. I say x inverse, what is it please? And the calculator has just told me 59.1. So type that in and make sure you get 59.1 as well. Now that found me, it's this value here. I've just found that that value there is 59.1. But notice it's a two-tailed test, so I need to find this value as well. So have a think for a bit. What do you reckon the area would be? The area is the value to the left of that. What area would be to the left of that? Well, it's only 2.5% above it, so I reckon that's 97.5%. Notice here, I've got 97.5% for the right-hand side. Again, sigma is the same as before, mu is the same as before. I type it in, I press go, and it says x inverse is 60.9. Now these then are my critical values. My 59.1 is the lowest that I would be willing not to reject H0. If it goes beyond 59.1, you know what? I'm going to say reject H0. Likewise 60.9. If I go beyond 60.9, I would reject H0. So let's do another example. It says if x is normal with mean 125, so again, just do a little picture. And it says the mean is 125, so I put that down the middle, that's 125. And variance is 9, so presumably I could write x is normal, 125, 9. Certainly x bar is normal, and I'm going to write it's 125, but now what's my n? My n is 20, so it's 9 over 20. Okay, what my H0 would be that mu equals this 125. Does it say if it's a one-tailed test or a two-tailed test? Ah, no, look at that. It gives me them. I didn't spot those before. It says H1, mu is greater than 125. So mu this time. This is a one-tailed test. So we are now being asked, what would the value be such that this critical region that I'm after, this critical region, notice, is that going to be over here? Because it says greater than here, I'm going to write greater than. But this time it's not two-tailed, it's not both ways. Here I was told it was a two-tailed test, so I had to share the 5% between both ends. But this time I don't. It says 5%, this is 5%. So I think this time I'm going to set my area equal to 0.95. I'm basically saying to the left of that point there's 95%. You've got to get your head around. There's two types of question, one tail or two tail. Area is 95%. My sigma would be the square root of 9 over 20. My mu is what is it? It's 125. And a big question is, what does the x inverse say? So I'm going to type it in now. So menu 7.3. Area was 0.95. It was the square root of 9 divided by 20, close bracket, and 125. And it says for me 126.1. Is that what it says? Now notice what I've said, it's greater than 126.1. So this value here, my x value, which coincides with that, anything more than that is essentially big enough. So we've got two different things here. We've got a critical value. The critical value equals 126.1. But the critical region, which of course it asked me to find, is any number bigger than 126.1. So I've written x bar is bigger than 126.1. So the next question, this is actually an old exam question from OCR. So it says the time t seconds needed for a computer to be ready for use from the moment it is switched on is normally distributed. All right then. So let's just write that down. Where's my pen gone? It's there. It's t, because they've said t, so I shall use it, is normally distributed. It says, does it give me the mean? Mean time is 30. Standard deviation 5, so I'll write that as 5 squared. Now, we always do a sample. One tail test is carried out, and we do a random sample 10 times. So you can see t bar is normally distributed 30, comma, well, it's 5 squared divided by 10. So we've got the distribution. I'm going to write out the hypotheses. H0 would simply be mu equals 30. And H1, the alternative, what's it ask for? Find a critical region. Just seeing if it says is therefore carried out at the 5% significance level as to whether the specification is being met. So we want this computer to turn on within 30 seconds. If it's better than 30 seconds, that's fine. I think we are testing to see whether it's bigger than 30. I think it's a one-tail test. It'd be quite easy to do this as a two-tail test, but I suspect, and I haven't checked, I suspect it's a one-tail test. So normal distribution, there it is. We think that mu is 30. We are looking for a value bigger than 30 because we're basically saying at what point would we go, do you know what, it's not quick enough, this computer. So we're looking for what they're calling T-bar. So they've said call it T-bar, so I have. And what percentage? They said 5%. But it's a one tail, so all of the 5% is down one end. 5%. You've got to get your head around whether it's one tail or two tail. So what are we doing? We are going to set our area equal to 0.95. 95% is to the left, and it's always to the left. Our sigma equals the square root of 5 squared over 10. Our mu is 30. So what does our x inverse say? One calculator. Right. So I'm going to go 0.95. I'm going to go the square root of 5 squared divided by 10, close bracket, and 30. And my x inverse says, according to me, x inverse equals 32.6. So my critical region, and this is what we've got to get used to writing this properly. It wants the region, doesn't ask for the value, it says what's the critical region. So we say T bar, if it's bigger than 32.6, we would reject H0 and we would be concluding that this 30 value is wrong. So I think that's what the answer should say. That's it. They've got 32.6, that's good. They've got that. That was worth 3 marks in the mark scheme. Saying it was bigger than was got you the extra mark. Okay, then the final question. We've got a wild cat, and in the wild it is known to have a mean of 13.5 and a standard deviation of 1.5. Okay, so I'm going to say x as is normal, 13.5, comma 1.5 squared. And presumably I'm going to do a sample. Yep, it says a sample of 4 wild cats. So as soon as I see that, I think x bar is normal, 13.5, comma 1.5 squared over the 4. And presumably this is a normal distribution. And there's my 13.5. Now what's it say in the question? It says we want to see, has it changed? And it's a 5%. So just bear that in mind. Has it changed? It doesn't specify which direction it's changed. So my 5% has got to be shared, 95% in the middle, 2.5% each end again. We've seen that before. So 2.5% each end. So for this left-hand end, I'm going to say area equals 0.025 again. My sigma is the square root of 1.5 squared over 4. My mu equals 13.5. I just type those in. So it's 0.025, the square root of 1.5 squared divided by 4, close bracket, and 13.5. Now I get 12.03 for the left hand side. Now obviously I'm not going to get the time to finish this, but can you see if you can finish it? And I want to know what the other critical value is. The question says find the critical region. So again, these are my answers, but again, when you find this second answer, it will have to be lower than that and greater than this. And these are my answers. I got 12.0 and 15.0. See if you agree with that. And there's also the second part of that question. Have a look at that, because in lesson we're going to do exercise 18b.